Namaskara, I am Vinay Kumar, Principal, KLE College. Today we will be discussing the basic concepts in chemistry. This chapter is very important as far as the competitive examinations are concerned and also in understanding a number of chapters in physical chemistry. The fundamental concepts that a student need to learn in chemistry are mole concept and equivalent mass, concentration of solutions, gram molar volume, Avogadro number, mole fraction and so on. Coming to the mole concept, first of all, why do we have the mole concept? Molecules are extremely small in size, their mass is very less, and when we try to express the amount of substance involved in a reaction in terms of molecules, you land up with huge numbers. For our convenience, we have the concept of mole. What exactly we mean by mole is, it is that amount of the substance which contains Avogadro number of atoms or molecules. Avogadro number is 6.02 into 10 power 23. So, any amount of substance which contains 6.022 into 10 power 23 atoms or molecules is called 1 mole. Coming to solution, a solution is a homogeneous mixture of two or more components. In a simple solution, there are only two components, and as far as we are concerned in this particular chapter, we deal with simple solutions where you have two components. One of them is called the solute and the other is called the solvent. When you dissolve a solid in a liquid, then the solid is called the solute and the liquid is called the solvent. However, it should be noted that that component which is present in smaller proportion is called the solute and that which is present in larger proportion is called the solvent. Depending on how much of solute is dissolved in how much of solvent, we have different ways of expressing concentrations of solutions, and what is relevant to us as far as the questions that appear in the examination are concerned are molarity, molality and normality. Later on, dear students, when I take up the numerical problems, I will be giving you the formulae to calculate molarity, molality and normality. Then we also have the concept of mole fraction. This also will be discussed in detail when I discuss questions relating to mole fraction. Then we have gram molar volume. Supposing the substance is in gaseous state. The volume of a gas depends on the pressure and temperature at which the volume is measured. And if you take 1 mole of any gas at STP, STP is standard temperature and pressure. Whatever volume 1 mole of a gas occupies at STP, that is called the molar volume. And the molar volume value is 22.7 dm cube or 22,700 cm cube or 0.0224 meter cube. Dear students, we will have to work out a number of problems where we need to convert number of molecules into moles, moles into volume and vice versa. Then I have already spoken about Avogadro number. Having understood what these concepts are, we will now go into specific questions and mainly the numerical problems which if you are able to solve properly, your concepts will be cleared. Dear students, let us take this question. The question is 80 grams of oxygen contains as many atoms as in option A 8 grams of hydrogen, option B 1 gram of hydrogen, option C 10 grams of hydrogen, option D 5 grams of hydrogen. Now, how do we go about solving this question? Dear students, here we need to apply the concept of mole. 1 mole is that amount of the substance which contains Avogadro number of molecules or atoms. Now, coming to oxygen, oxygen molecule is diatomic. So, here we need to know how many moles of oxygen molecules are present in 80 grams of oxygen, for which we need to know the molecular mass of oxygen. Dear students, please remember that 1 mole of any substance will have a mass equal to its molecular mass. The molecular mass of oxygen is 32, and therefore, the number of moles of oxygen in 80 grams of oxygen is 80 by 32, which turns out to be 2.5 or say 5 by 2. So, here please note, oxygen is molecule in diatomic state, but what's asked in the question? How many atoms are present? Therefore, the number of atoms that would be present in 5 by 2 moles of oxygen would be 5 by 2 into Avogadro number, which gives the number of molecules, into 2, which gives the number of atoms. So, now we know how many atoms are present in 80 grams of oxygen. That would be equal to 5 by 2 into Avogadro number into 2. Now, come to the options. We have to look for that option which gives this number. Now, the first option is 8 grams of hydrogen. The number of moles in 8 grams of hydrogen is 8 by 2, where 2 is the molecular mass of hydrogen. The number of moles in 1 gram of hydrogen is half, and in 10 grams of hydrogen is 10 by 2, that is 5, and in 5 grams of hydrogen it is 5 by 2. So, here we have 5 by 2 moles of hydrogen, and coming to the number of atoms, since hydrogen is also diatomic, the number of atoms in 5 by 2 moles of hydrogen would be 5 by 2 into Avogadro number into 2. Hence, the correct option is D, that is 5 grams of hydrogen. Hence, option D is the right answer. Next question. This question is based on the concept of gram molar volume. The question is, the mass of 112 centimeter cube of methane at NTP is, the options are 0.16 gram, 0.8 gram, 0.08 gram and 1.6 grams. Dear students, gram molar volume is the volume occupied by 1 mole of a substance or 1 gram mole of a gas at NTP or STP. At NTP, the value is 22.4 dm cube or 22,400 cm cube. And we also know that 1 gram mole of a substance is nothing but the molecular mass of the substance expressed in grams. The substance here under consideration is methane. The molecular mass of methane is 16. 16 grams of methane at NTP occupies 22,400 cm cube. In other words, 22,400 cm cube of methane at NTP weighs 16 grams. But in the question, we need to calculate the mass of 112 centimeter cube of methane. Therefore, the mass of 112 centimeter cube of methane at NTP will be equal to how much? And that is equal to 16 into 112 by 22,400. and this turns out to be 16 by 200, or that is equal to 0.08 grams. Hence, the correct answer for this question is option C, that is 0.08 grams. Next question, a compound has molecular formula X4O6. If 10 grams of X4O6 has 5.72 grams of X, then calculate atomic mass of X. The options are: first option 32 units, second option 64 units, third option 67 units, and fourth option 98 units. My dear students, this is a problem which is based on the relationship between atomic mass and molecular mass, or atomic weight and molecular weight. Please note that the sum of the atomic masses of different elements present in a molecule of the substance will be equal to its molecular mass. Now, which is the compound that we have? It is X4O6. Supposing we say that the atomic mass of X is A, then the molecular mass of X4O6 will be 4A plus 16 into 6, where 16 is the atomic mass of oxygen, that is 96. The molecular mass of X4O6 is 4A plus 96. 4A plus 96 grams of X4O6 contains 4A grams of X. Now, what do we want in this particular question? We have to know the atomic mass of X, that is, we have to evaluate the value of A. So, here 4A plus 96 grams of X4O6 contains 4A grams of X, but here we have taken 10 grams of X4O6. Therefore, 10 grams of X4O6 will contain how much of X? That will be equal to 4A into 10 divided by 4A plus 96. And this is equal to, as given in the problem, it is equal to 5.72. In order to calculate the value of A, we need to cross multiply. And when you cross multiply this equation, you get that the value of A is equal to 32.7 units. And therefore, the right answer for this particular question is A, that is 32 units. Next question, 2 grams of metal carbonate is neutralized completely by 100 ml of 0.1 normal HCl. The equivalent weight of the metal carbonate is option A 50, option B 100, option C 150, and option D 200. Dear students, this problem is based on the concept of equivalent mass. what we need to know here is that whenever two substances react, equivalent mass of one substance reacts with equivalent mass of another substance, or in other words, if X equivalent of a substance reacts with another substance, then the number of equivalents of that substance which has reacted completely will also be equal to X. In this question, the two substances involved are, one is metal carbonate and another is HCl. How much of HCl? It is 100 ml of 0.1 normal HCl. What we need to do here is to calculate the number of equivalents or equivalent masses of HCl in 100 ml of 0.1 normal HCl. And the formula to calculate the number of equivalent masses is V into N divided by 1000. What is the volume of HCl given in this problem? It is 100. Normality is 0.1 divided by 1000. And that would be equal to 0.01. Dear students, please note that the number of equivalents in 100 ml of 0.1 normal HCl is 0.01. If 0.01 equivalents of HCl are present in this solution, then it should have reacted with 0.01 equivalents of metal carbonate. So, number of equivalents of metal carbonate is also 0.01. But what is asked is the equivalent weight of metal. And please note that 0.01 into E, that is number of equivalents, into equivalent mass should be equal to the mass of the substance, which is equal to 2. And therefore, the equivalent mass of metal carbonate will be 2 by 0.01, which is 200. And hence, the correct answer for this particular question is option D, that is 200. The next question, an alkaloid contains 17.28% of nitrogen and its molecular mass is 162. The number of nitrogen atoms present in one molecule of alkaloid is option A 5, option B 4, option C 3 and option D 2. Dear students, it is given that the alkaloid contains 17.28% of nitrogen, which means that 100 grams of the alkaloid contains 17.28 grams of nitrogen. But here the molecular mass of alkaloid is given as 162. Therefore, if you consider 162 grams of the alkaloid, the mass of nitrogen present in it will be equal to, definitely it has to be more than 17.28, and when we calculate it, you will find that it is equal to 17.28 into 162 divided by 100, which is approximately 27.9 or 28. Therefore, in 162 grams, that is, in one molecular mass of the alkaloid, the mass of nitrogen present is 28 grams. But in the problem, we have to calculate the number of atoms. How do we go about this? Please note that the mass of nitrogen is 28, its atomic mass is 14, and therefore, the number of atoms of nitrogen present in 162 grams of the alkaloid will be equal to 28 by 14, which is equal to 2. And hence, the right answer is option D. Next question, for the reaction represented by the equation CX4 plus 2O2 giving CO2 plus 2X2O, 9 grams of CX4 completely reacts with 1.74 grams of oxygen. The approximate molar mass of X will be option A 20, option B 40, option C 60, option D 80. Dear students, we have to look into the stoichiometric equation. As per the stoichiometric equation, that is the balanced chemical equation, 1 mole of CX4 reacts completely with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of X2O. Now, what is given in this problem? 9 grams of CX4 completely reacts with 1.74 grams of oxygen. As per the stoichiometric equation, the number of moles of oxygen which has reacted completely is 2 moles, which turns out to be 64 grams. Therefore, 64 grams of oxygen will react how much of CX4? And this will turn out to be 64 into 9 by 1.74, that is 331. Therefore, the mass of CX4 that reacts is 331, and as per the stoichiometric equation, that is equal to 1 mole. Hence, the molecular mass of CX4 is 331. We know that the molecular mass is the sum of the atomic masses of the different elements present in one molecule of the substance. The substance is CX4. Atomic mass of carbon is 12. Let us say the atomic mass of X is A. Then 12 plus 4A should be equal to 331. 4A is equal to 320, which means that A is 80, and that is the atomic mass of X. And hence, the right answer for this question is option D, that is 80. Next question, for the non-stoichiometric reaction 2A plus B giving C plus D, the following kinetic data were obtained in 3 separate experiments at 298 Kelvin. In experiment 1, initial concentration of A 0.1, B 0.1, and initial rate of the reaction 1.2 into 10 to the power minus 3 mole per liter per second. Second experiment, concentration of A 0.1, concentration of B 0.2, and the rate 1.2 into 10 to the power minus 3 mole per liter per second. Third experiment, concentration of A 0.2, concentration of B 0.1, and the rate of the reaction 2.4 into 10 to the power minus 3 mole per liter per second. The rate law for the formation of C is dC by dt is equal to A, K into concentration of A into concentration of B, B, K into concentration of A squared into concentration of B, C, K into concentration of A into concentration of B whole squared, and option D, K into concentration of A. Students, you have to know that this is a non-stoichiometric equation. And what is order? It is the sum of the powers to which the molar concentrations of the reactants are raised in the experimentally determined rate equation. And note that in order to get the experimentally determined rate equation, we have to carry out experiments, vary the concentrations of the reactants individually, and find out as to what happens to the rate of the reaction. And by looking into the rate of the reaction and also into the concentrations, we can say of what order the reaction is with respect to a particular reactant. Now let us say the rate of the reaction is R is equal to K into concentration of A to the power X into concentration of B to the power Y. If you are able to get the values of X and Y from the data, then we will be able to arrive at the overall order of the reaction. Observe experiments 1 and 2. Concentration of A is kept constant. Concentration of B alone is increased from 0.1 to 0.2, but there is no change in the rate of the reaction, which means that the rate of the reaction is independent of the concentration of B, and therefore the value of Y is 0. Now observe the data of experiment 1 and experiment 3. Concentration of A is increased from 0.1 to 0.2. Concentration of B is kept constant, and you find that when the concentration of A is doubled, the rate of the reaction also gets doubled, which means that the value of X is 1, and therefore the rate equation R, or you may say dC by dt, will be equal to K into concentration of A to the power 1 and into concentration of B to the power 0. And therefore, the correct answer for this particular question is option D, that is K into concentration of A to the power 1. Question: in the reaction P plus Q giving R plus S, the time taken for 75% reaction of P is twice the time taken for 50% of reaction of P. The concentration of Q varies with reaction time shown in the figure. The overall order is option A 2, option B 3, option C 0, option D 1. Now, students, please note that whenever you have to determine the overall order of a reaction, you have to write down the experimentally determined rate equation. Let us say the rate equation is R is equal to K into concentration of P to the power A into concentration of Q to the power B. If we can find out the values of A and B from the data, then we will be able to know the overall order of this reaction. What is said in the problem? The time taken for 75% reaction of P is twice the time taken for 50% of the reaction. What is half-life period? It is the time taken for the concentration of the reactant to reduce to half of its initial value. Supposing the initial concentration is 100. For 100 to become 50, it takes one half-life period. For 50 to become 25, it becomes it takes another half-life period. For 100 to become 50, it takes one half-life period, and for 50 to become 25, it takes another half-life period. And when 100 becomes 25, 75% of the reaction would be completed, and this happens in case of a first order reaction, because in a first order reaction, the half-life period is independent of the initial concentration, and therefore the order of the reaction with respect to P is 1. Now A value is 1. How do we find out the value of B? For that, a graph is given here. This is the concentration of Q at the start of the reaction, and the graph shows the variation of concentration of Q with respect to time. You find that it is a linear graph, and because it is a linear graph, the order of the reaction with respect to Q is 0, and therefore the value of B is 0. So when A is 1, B is 0, the overall order of the reaction is A plus B, and that will be equal to 1, and hence the correct option for this particular question is option D. Question: 75% of first order reaction is completed in 30 minutes. What is the time required to complete 93.75% of the reaction? Option A 45, option B 120, option C 90, and option D 60 minutes. Students, here you have to note that it is a first order reaction. In a first order reaction, the half-life period is independent of the initial concentration of the reactant, which means that if you start with 100 moles, to become 50, it takes one half-life period. And from 50 to become half of it, 25, it takes another half-life period. For 25 to become 12.5, it takes another half-life period. And for 25 to become 6.25, it takes another half-life period. What you have to note here is that the time taken for 75% completion is 30 minutes, and the time taken for 75% completion, which means 25% remains, is 2t half. That is, twice the half-life period is equal to 30 minutes, and therefore one half-life period will be equal to 15 minutes. But what are we to find out in the question? We are asked to find out the time taken for completion of 93.75% of the reaction. When 93.75% of the reaction is complete, 6.25% of the reactant remains. And as we observe here, for 6.25% of the reaction to remain, or 93.75% of the reaction to be completed, it takes 4 half-life periods, and therefore the time would be 4t half, that is 4 times 15, which turns out to be 60, and hence the correct option for this particular question is option D, that is 60 minutes. Question: an organic compound undergoes first order decomposition. Time taken for its decomposition to 1/8 and 1/10 of its initial concentration are T 1/8 and T 1/10. Then T 1/8 by T 1/10 into 10 is, the options are A 2, B 3, C 5, D 9. You are given log 2 as equal to approximately 0.3. Students, please note that this is a question from JEE advanced paper. Now, how do we go about it? It is a first order reaction. For a first order reaction, we know that T is equal to 2.303 by K into log of concentration of A naught by concentration of AT, where concentration of A naught is the initial concentration, concentration of AT is the concentration of the reactant at time t. Now, in the problem it is asked to find the ratio of the time taken for 1/8 of the reaction, and when T 1/8 will be equal to 2.303 by K into log of concentration of A naught by concentration of A by 8, A naught by 8. Then T 1/10 is equal to 2.303 by K log of concentration of A naught by concentration of A naught by 10. Therefore, T 1/8 by T 1/10 will be equal to log 8 to base 10 by log 10 to base 10. Log 10 to base 10 is 1. Log 8 to base 10 can be written as log 2 to the power 3 to the base 10, that is 3 log 2, that is equal to 3 into 0.3, that is equal to 0.9. But what are we to find out as per the problem? We have to find out T 1/8 by T 1/10 into 10, that would be 0.9 into 10, that would be 9, and therefore the right answer for this question is option D, that is 9. Question: the first order reaction is 60% complete in 20 minutes. How long the reaction takes to be 84% complete? Option A 68 minutes, option B 40 minutes, option C 76 minutes, option D 54 minutes. Dear students, please note it is a first order reaction, and for a first order reaction T is equal to 2.303 by K into log A by A minus X. As per the problem, you are given the time taken for 60% completion and you are asked to find the time taken for 84% completion. So, what will happen is T1 by T2 will be equal to, if you divide, you will find that it will be equal to log of A by A minus X by log of A by A minus Y, where the value of X is 60, supposing you take A as 100, and the value of Y is 84, and therefore T1 by T2 will be equal to log of 100 by 40 by log of 100 by 16, of course to the base 10. Now, when you simplify this, you get T1 by T2 is equal to log 100 minus log 40 divided by log 100 minus log 16. So, T1 by T2 is equal to log 100 is 2 minus log 40 is 1.6021 divided by log 100 is 2 minus log of 2 to the power 4, that is 4 into log 2, that is 4 into 0.3010, approximately 0.2, and T1 is 20. So, 20 by T2 will be equal to approximately 0.4 by 0.8, that is half, or T2 will be equal to 40. and therefore, the right option for this question is option B, that is 40 minutes.